says the equilibrium constant is 8.79 blah 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 times 10 to the minus fifth at 63 degrees Celsius for the following reaction. Lead 2 chloride solid goes to lead 2 plus ion plus 2 chloride ions. It says right in the problem statement, because lead 2 chloride solid is a solid, you don't need an initial concentration to solve this problem. Remember, solids don't appear in equilibrium constant expressions and are left blank in ice tables. Question, what is the concentration of Cl minus? Yes, this will be our last problem on this lecture outlines, or this homework for this week, and it is an ice table problem. So we write our reaction. We write our ICE for initial change in equilibrium concentrations. We see that this is a Kc value, so this is in terms of molarity. In fact, we've not worked an ice table problem in terms of pressures yet, but I'm okay with that. All right, so this note here, because lead 2 chloride is a solid, you don't need an initial concentration to solve this problem. Remember, for solids, we just put a big X to remind us never to write anything else there. And now we know that our initial concentrations are typically 0, and that's true. And our changes, plus X and plus 2X, because we have a 2 coefficient. And now we can continue with our regular process for solving ice table problems, which goes like this. Write out your equilibrium constant expression in terms of product concentrations over reactants. Don't include solids or liquids. There is no there is no reactant that we include in our equilibrium constant. So this would just be over 1, and I won't write that this time. We now know that our equilibrium concentration of lead 2 is just X, of chloride is 2X, and that is squared. And our value for Kc is 8.79 times 10 to the minus fifth. And what's nice about this is there is no quadratic to solve. Let me see. So 2 times 2 squared is 4. X squared times x is cubed. And take this number, divide it by 4, and then take the cube root. Do I have a cube root button? Yeah, there it is. Shift. And I get 0.0280 molar as my x. And chloride will be twice as much. .0560 molarity, or molar. And that is our last ice table problem.